So today we're going to find actual confidence intervals. Yesterday we did the building blocks. We found out about margin of error, which is the distance between the center. So if you have a curve, right? Let's say I'm finding a 90% confidence interval, so that'll be this in here. The margin of error is the distance between the center and the top of the block, or the bottom of the block. This thing right here. And then remember, to find your confidence intervals, you have to make sure that you have a z critical at the top and a z critical on the bottom. So basically what you do is you take a sample. Let's say I'm taking average income, right? I want to see what the average income of the American people are, right? So it'd be impossible to find the actual average income because it would be way too many people. But what you could do is you could find a sample, find that average, right? That average will go in the middle, and then build a confidence interval saying that you're 90% confident that the true population mean is somewhere between a number on the low end and a number on the high end, right? And then if you want to be more confident, you make your confidence interval bigger, 99, 99.9. If you want to be less confident because maybe you have not as much money to run a good sample or something like that, you would make an 80% confidence interval or a 70% confidence interval. Okay, so example 1, build a 90% confidence interval for the average height if our sample has an average height of 68 and a standard deviation of 2. If we have 18 people in our sample. So 18 people in the sample, what I would do here is I would draw a curve, right? Our little normal curve, because all these means are going to be normally distributed, and it's going to be 18. So we want to find a 90% confidence interval. Right, so the first thing we have to do is we have to find out what those z's are going to be. So we go invert norm. This is what we practiced yesterday. So you can either type in 0.9, comma, and then do the middle thing if you have the new calculator. I'll just show you on the old calculator how you do it. So you have 10% left in the tails here, so 10% here and here, which means I have 5% here and 5% here. So if I go invert norm 0.05, that will give me, let's do that on the calculator real quick, invert norm 0.05. 0 is the mean, 1 is the standard deviation, boom. You get negative 1.644. So that's going to be your z here, 1.644. On this side, a negative 1.644. So that's 1.644 standard deviations away from your mean. Okay? Now what we have to do is we have to find our mean. So we know that the mean, they told us, was 68. So basically I'm going to have a number and I'm going to add 68 to it, and I subtract 68 from it. I have to find what that margin of error is. Last thing we have to find is the standard deviation. So the standard deviation of each of the sample is 2, but then we have to divide by the square root of 18 because we're talking about the sample mean. So 2 divided by the square root of 18. So we get our standard deviation to be 0.47. So now what I have to do is I have to take that and I multiply, that's the standard deviation. So if I take the standard deviation times the number of standard deviations, that will give me my margin of error, right? It'll give me my distance between the mean and that low and high block, right? So I got to find what those are. So I take that standard deviation and I multiply by my z-score, 1.644. So that'll give me a margin of error of 0.7749, right? So what I have to do now, 0.77, is I have to take 68 and I have to add that to it. So that'll give me 68.7749, and I have to subtract that. So 68 minus 0.7749890322, 67.25. Okay, and then the final context, right? So I'm 90% confident that the true mean height of 18 people is between 67.25 inches and 68.77 inches. Okay. There is a shortcut on the calculator. Let me just show you that real quick. So if I go second distribution and I go to invert norm, show you here. If I go second distribution, let me light this up a little bit. Second distribution, invert norm. I leave that as 0.05, but I can change my mean. Yeah, you know what? Yeah, I can do it. Let's change it. So let's change my mean to, let's see here. We got 68. And let's change my standard deviation to 2 divided by the square root of 18. And we want to find the left. Actually, if you have the new calculator, we'll just go crazy. We'll do 0.9. So we got our 90% confidence interval, mean, standard deviation. We want the center. Right? Your calculator will do it all for you. So there you go. That's what I got. 90% confident. The mean is between here and there. Okay. Cool. So calculator can do it in a couple button pushes. It's important though that you draw the curve so at least you understand what the mean and standard deviation are. Okay, last one here. Build an 80% confidence interval. So this is going to be a confidence interval of 80, right? We're looking at phone usage, right? So the mean phone use is going to be 175 minutes. And the standard deviation is going to be 28 minutes, but we have 35 people in our sample. We want to build an 80% confidence interval for how much time people are actually spending on their phones. Right, so the first thing we have to do is we have to find those Z stars, or those Z C's, those critical Z values. So we go second distribution, invert norm. We want the middle 80%, which means we have 20% left over. So we have 0.1 on this side and 0.1 on that side. So you can do 0.1, make your mean 0, standard deviation 1. We're going to go left because you probably have the old calculator, so 0.1. That gives me negative 1.2815. Okay, so that's going this way. 1.28 standard deviations and going this way, 1.28 standard deviations. So now to find the margin of error, I have to take this number, I have 1.28, that's the number of standard deviations, and multiply by 28 over the square root of 35. That will be the distance between the center and the high and the low blocks. So take that times 28 divided by the square root of 35. Make sure you put that in parentheses. That gives me negative 6.065. So basically now that's your margin of error, 6.065. So you just take this, add the margin of error, and subtract the margin of error from it. So 175 plus 6.065, that's going to give me 181.065, and then do the same thing, 175 minus 6.065. It's going to give me 168.93. So I'm 80% confident that the average phone use is actually between 168.93 minutes and 181.064 minutes, 65 minutes. If I want to do that on the calculator real quick, I'll just go second distribution. I want to do invert norm. I want my area, I want an 80% confidence interval. My mean was 175. My standard deviation was 28 divided by the square root of 35. Close. We want it to be a center. Paste. There you go. 168, 181, just like we said, right? So those are the nuts and bolts. That's how you do it on the calculator. You got a little bit of math Excel tonight. Peace.